discuss this question. A circular disk of radius b has a hole of radius a at its center. If the mass per unit area of the disk varies as sigma naught by r, then the radius of gyration of the disk about its axis passing through the center is. So this is the annular disk which is shown in figure, and we have to find the radius of gyration. Basically, radius of gyration is k. Okay, we have to find this k, and the formula is the moment of inertia is equals to mk square, right? So we have to find k from this, but right now we have to find the moment of inertia of this disk first. Now we can't use simply formula of annular disk right over here, since the mass is varying inversely to the radius which is given right over here. This is the density, right? So uh, first we have to find inertia. So when mass is varying, inertia is integral dm r square, right? So we have to find dm mass first, right? So if I just second, wait a second. Yeah. So now I have to find dm first, right? So this dm can be written as, like, we have mass per unit area. What is given? Mass per unit area is sigma naught by r. Okay, so let's take an element. Since this is a disk, the element would be our ring. Okay, so I'm taking a ring at r distance of dm mass. Okay, so this ring is like this, of r radius and dm mass. If I just cut this out, okay, if I just cut this out, this ring can be shown like this. Perfect. So the length of the ring will be equal to the perimeter of the ring, which is nothing but 2 pi r. Okay, so the length is 2 pi r, and the thickness is dr. Perfect. So the area of this ring, or this line, would be uh, length into breadth, which is 2 pi r into dr. So from here we can write that mass is dm and the area is 2 pi r dr. Okay, which is equals to sigma naught by r, which is our density. So dm can be written as this r and r would get cancelled out, and this dm can be written as sigma naught into 2 pi dr. Perfect. So this is our dm. So now I have to find moment of inertia, and then we can find out our radius of gyration. Okay, so for inertia, we know this integral dm r square is used for mass varying rigid bodies. Okay, so right now we know dm also. So what would be the limit of this? This disk is varying from a to b, so the limit would be a to b. Perfect. So what, let's put the value of dm, which is sigma naught into 2 pi dr basically r square into dr, okay, from A to B, right? So this 2 pi sigma naught is constant, which is 2 pi sigma naught into r square dr. We have to integrate r square dr, which is nothing but r cube by 3, and the limit would be from A to B, okay. So the inertia would be 2 pi sigma naught upper limit minus lower limit, so B cube minus A cube. This is my moment of inertia. Perfect. Now just we have to find a radius of gyration, right? Before radius of gyration can be given as mk square, so we have to find m, and we know dm. What is our dm? That is I guess sigma naught 2 pi dr, right? Okay, so sigma naught 2 pi dr, we can integrate this to get m, right, which is sigma naught 2 pi r. Perfect, because of dr, okay. So now we know m, we know moment of inertia, we can find our k, which is k would be given as under root of I by m, right? So radius of gyration is under root of 2 pi sigma, here we have to put limit here, no, A to B, right? So this r would vary from A to B, okay, from A to B. So this mass can be given as sigma naught 2 pi upper minus lower. Perfect. So this, what is inertia? That is 2 pi sigma naught b cube minus e cube divided by, what is m? M is sigma naught 2 pi b minus a. So this 2 pi sigma naught, 2 pi sigma naught would get cancelled. This k can be written as this 3 is missing, right? So here 1 over 3, okay, and b cube minus a cube, we know this formula, b minus a, b cube minus a cube is written as b minus a into a square plus b square plus ab. So divided by b minus a, so this would get cancelled out, and we will get a square plus b square plus ab divided by 3 and root, and this is our radius of gyration, okay, which is our option number C, okay.